Okay, welcome to lesson 6.2 on radian measure and angles on the Cartesian plane. We're going to start today again with another warm-up. So in yesterday's homework handout, you looked at the acute special angles. So that was for 30 degrees, 45 degrees, and 60 degrees. But we changed those into radians. So we looked at pi by 3, pi by 6, and pi by 4 on the unit and on the unit circle. Today we're going to look at the special angles that land right on the axes. So at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. As you know, in standard position, the initial arm of a rotational angle is on the positive x-axis. So we've talked about that before. So here would be my initial arm. And then the terminal arm rotates counterclockwise from there. If we rotate in the opposite direction, we would have a negative angle of rotation, which we don't typically look at. So in standard position, we're rotating in a counterclockwise direction. We're going to take a look at this triangle here on the axes, and you can try to do this warm up on your own if you want. I'm just taking it up. In the triangle that I've drawn here, I've drawn my point XY in the first quadrant, but this would work for any quadrant. Once I drop my terminal arm, I'm going to connect it to the x-axis. So I'm dropping from the point on the unit circle down to the x-axis to make a 90-degree triangle. And then I've got my angle theta here nestled in next to the origin. I can label the hypotenuse of this triangle with the r, the radius. And then if the point is actually over to x and up to y, then I can also label the base here of my triangle is x, since I've gone over to the x coordinate, and then the height of the triangle, I can call that y. So then I can fill in my ratios using SOHCAHTOA. I'm thinking about using angle theta in here as my angle, and so of course the opposite would be y, the adjacent would be x, and the hypotenuse would be r. And then I can use SOHCAHTOA to help me out. So sine theta is the opposite over the hypotenuse. So in this case, it'd be y over r. And then the cosine of theta is the adjacent over the hypotenuse. So here the adjacent is x, and the hypotenuse is r. And then tan of theta is going to be the opposite over the adjacent, so y over x. And then what we're going to do is consider, well, what happens if it's a unit circle? So a unit circle, you're going to hear this phrase a lot in trigonometry. The unit circle is just when I'm assuming that the radius of the circle is 1. And then I can fill this in, so it's going to be the exact same as over here, except instead of x, y, and r for radius, it's x, y, and 1 for radius. So now when I think about the sides of my triangle, I still have that the opposite of the angle is y, and the adjacent of the angle is x. I've got that 90-degree angle in there. It was over here as well. And then here the radius or the hypotenuse is 1. So sine of theta is the opposite over the hypotenuse, so now it's y over 1, but we know that y divided by 1 is just the same as y. And then cosine of theta is going to be the adjacent x over the hypotenuse 1, but x over 1, that's just x. And then tan of theta, well, tan is the opposite over the adjacent. Nothing changing here, it's still just y over x. But sine and cosine become more interesting. So when I'm rotating around a unit circle, this is how we come up with the graph of sine of theta, right? When we just look at the radius as being 1, then the y values, the height of the graph, will be equal to sine of theta. Anyways, back to our unit circle, we're going to look at these ratios here. We're just using a unit circle in the rest of the examples. So I know that sine theta is always the y value, cos theta is the x value, and tan is the y divided by the x. So looking at these diagrams below, I'm going to first state the angle in radians, then draw the terminal arm for the given angle, and then state the trig ratios for each angle. So first we've got here theta is 0 degrees, and 0 degrees in radians is still 0. Oh, sorry. Wrong tool. So 0 degrees is 0 radians. And then I'm going to draw in my terminal arm. And my terminal arm here is just along the x-axis. You can put the arrow on the end, but you don't need it. And then I'll go back to my pen tool. Now we're going to state the trig ratios for each angle. So here I can't even really draw my angle on the picture because it's just 0 degrees. You could also think of this as 2 pi or a 360-degree rotation. But here, this is what we've got. Notice that in this picture, I can state the x, y, and the r values. If I'm thinking about the point that I end up on the unit circle here, this point is over at 1 and up at 0. So my x value is 1, my y value is 0, and of course the radius of the circle is still 1. So here are my values. Sine of theta, that's the opposite, y over the radius, 1. So y here is 0. So it's 0 divided by 1, which is just 0. And then for the cosine, it's just x over r, or 1 over 1. That's equal to 1. The tan value is going to be the y over the x. So 0 over 1, that's also equal to 0. And so I come up with my 3 values here. And we know that sine theta, sine of 0 is 0, right? We can think about our sine curve as well. And then cos theta starts at 1. So again, if I was thinking about my cosine curve, it starts up at a value of 1. Now remember that cosecant is just the reciprocal of sine. So sine was 0 over 1, thinking about the radius as being the denominator. When I flip that over to get the reciprocal, 1 divided by 0, I can't divide by 0, that's undefined. For secant of theta, that's the reciprocal of cosine theta. Now cosine theta was 1 over 1, x over r. And when I flip that over, it's still 1 over 1, and so secant theta is 1. And then cotan of theta, again, I'm just doing the reciprocal of tan. So tan was y over x, 0 over 1, but now cotan will be 1 over 0. And again, I can't divide by 0. So that's also undefined. The next angle we're going to take a look at is theta is 90 degrees. So we're going to think about, well, what would that be in radians? So a couple of different ways that you can convert that. You can be thinking about multiplying by pi divided by 180, or you could be thinking about the work that we did yesterday with sectioning out our grid, and we know that if I have 180 or pi radians in the top and 90 splits that in 2, that means I'm going to take the pi and split it in 2. Remember, the pi represents the top half. Again, I can draw in my terminal arm at pi by 2 radians. And then I can be thinking about, well, what is the x, y, and r values of this point here? So this point here, I've gone over 0 and up to 1. And so my x value is 0, my y value is 1, and again, the radius of a unit circle is 1. So sine of theta is the y value over the radius 1, so 1 over 1 is just 1. Cos theta is x over r, or 0 over 1, so that's 0. Tan of theta is y over x, so 1 divided by 0. Again, I can't divide by 0, so tan of theta is undefined for pi by 2 radians, or 90 degrees. And then I can do the flip, or the reciprocals, to find my cosecant, secant, and cotan. So 1 over 1 reciprocal is 1. 0 over 1 reciprocal is undefined. And then the undefined here, remember, that started as 1 over 0. When I flip that over, I get 0 over 1, which is allowed. And so cotan of 90 degrees, or cotan of pi by 2, is 0. Moving on to part C here, 180 degrees. Well, we know what that looks like, and we already know from our conversion yesterday that 180 degrees, that's just the same as pi radians. And then we can fill in our terminal arm. There it is. And then I can think about, well, what is the value of that point where it hits the unit circle? So don't forget, I'm just going to label my angle. There's my theta. I forgot to do it above. Starting at the positive x-axis, there is my theta. All right, so we want to think about what are the values for this point here. Well, this point here, I've gone over to -1 on the x-axis and up to 0. So again, I can state my x, my y, and my r value for this diagram. And then my sine value is just my sine of theta, or sine of pi, is 0. Cos of pi is going to be -1. And then tan of pi, that's going to be the y value divided by the x value. So tan of pi is 0. And then cosecant, just doing the reciprocal of these. So 0 over 1, the reciprocal is undefined. And then the reciprocal of negative 1 over 1 is negative 1. And then the reciprocal of 0 over negative 1 is negative 1 over 0, which is undefined. You can't divide by 0. All right, moving on to 270. So we might remember what 270 looks like. 270 is the one, the terminal arm on the negative y-axis. So there is going to be my angle. And then thinking about, well, what is that in radians? Remember that what I've done here is cut the circle into quarters, right? The first quarter being here at pi by 2, and then at pi or 2 pi by 2, and so then this next one will be 3 pi by 2. Or you can use our conversion methods from yesterday. I can label this angle in here starting at the positive x-axis, rotating counterclockwise, and there's my theta, which is 3 pi by 2. So I'm going to find sine of 3 pi by 2. To do that, I'm going to think about, well, what are the values of this point here where I hit that unit circle? And here my x value is 0 and my y value is negative 1. So x is 0, y is negative 1, and r is 1, the radius of the circle. So my sine of 3 pi by 2 is negative 1, cos of 3 pi by 2 is 0, and tan of 3 pi by 2, that's going to be the y over the x, so negative 1 over 0, and I can't divide by 0, so it's undefined. And then again, cosecant, just the reciprocal of sine, secant, the reciprocal of cosine, so now it's 1 over 0, that's undefined. And then cotan is going to be the reciprocal of tan, so it'll be, instead of y over x, the cotan will be x over y, or 0 over negative 1, which is just 0. All right, so this warm-up's going to come in handy when we're looking at the graphs in 6.3. So that's coming up in our next lesson. It's also important to notice that I can always go back to just drawing this general diagram where I throw the point P in the first quadrant, and it helps me remember the opposite over hypotenuse and the SOHCAHTOA version in terms of y, x, and r.